Hello everyone again. Let's take a look at some more material. This is practice test pertaining to Chapter 5 for the MATC class, Math 107. It is also useful for anybody else watching these videos with similar mathematical questions that can arise. By the time we're done with all these, we'll get into trigonometry, Pythagorean theorem, a number of items will be available to us when we're looking at all this. So let me adjust my microphone first of all. Here, make sure we got this right. Okay, so there's 20 problems here, and they're pretty decent. So let's take a look at it and see how they go. Let me try to find some chalk here and go for it. For question number 1 of 20, they're saying here, given this figure, find the perimeter of the following polygon. Be sure to include the correct unit in your answer. The term polygon is pretty interesting, and it's pretty interesting in its own right. Poly from the Greek word poly, gon from gonia, many-cornered, many-sided in a sense. Where there's many corners, there's going to be many sides as well. So for this polygon right here, how many corners are there? 1, 2, 3, 4, 5. 5 of them. It's a pentagon. It's not very symmetric, but it's a pentagon type of polygon. The perimeter is the measurement around. The units will be the same. So the perimeter is simply measuring around this. Let's start somewhere. Let's start right here and go all the way around, counterclockwise if you wish. 13 plus 12 is 25, plus 7 is 32, plus 11 is 43, plus 9 is 52. 52 yards. And that'll be your answer there. And you can always check these when we're done, make sure everything's on the mark. For number 2, they're saying find the perimeter of the square. Square is a figure that is a quadrilateral, 4 sides. It's a polygon with 4 corners. And it's a quadrilateral that is more specifically a rectangle, and more specific than that, it's a special kind of rectangle where all the sides are all the same length. All the sides are perpendicular to one another, and they are the same length. So basically, 11 plus 11 plus 11 plus 11 is 44 meters for the perimeter. And that'll be the answer there. Again, the units are the same. If I had apples, if there's a box of 10 apples, and then I had 20 apples, and then I had 30 apples, at the end of the day, there's 60 apples in there. They're not 60 apples cubed. When you're adding apples, you get more apples. You don't get any kind of unit change. The units are the same when you're adding these up. So, find the perimeter, I guess they were saying. So we got that. So there's 1 and 2 for you. For number 3, a dance floor is in the shape of a rectangle. It is 25 meters long and 24 meters wide. This is not really good scale. It almost looks like a square in real life, it should look like, because they're pretty close in length. But what we're talking about here is find the perimeter of the square. We already did that, but forgive me. A dance floor is in the shape of a rectangle. It is 25 meters long and 24 meters wide. What is its perimeter? If it's 25 meters here, it's 25 meters here. If it's 24 meters here, it's 24 meters there. Basically, 24 and 24 is 48. 25 and 25 is 50. 50 and 48 is 98 meters. So that's this one. You could have just, and basically this is what I did. I mean, we took the length, it's 25. If you double the length, double 25, you get 50. If you double the width is 24. Double 24, you get 48. 48 and 50 is where the 98 comes from. Okay? That's 1, 2, 3 right there. For 4, find the area of the square. As we said, because of the symmetry, the length and the width are the same. I don't have to do this if I was going to. 2 yards. For the they ask for the area. Well, call this the length, call that the width, and what you got is, here's the length, here's the width, (64 yards squared). 64 yards squared, 64 square yards. Yeah, area is in square units. Volume is in cubic units. Length, perimeter, circumference is linear units. So length, width, height, the perimeter of something, the circumference of a circle, all those are linear units. Meters, yards, feet, miles. So let's just say meters. I mean, we use meters for that. But you can use whatever you want, but they're linear units. Area is feet squared, yards squared, miles squared, meters squared. Volume is yards cubed, miles cubed, yards cubed, meters cubed. So a good way to remember it is linear measurement around linear units, not squared. The area is 2 dimensions squared. Volume 3 dimensions, put it to the 3. The only thing getting taken to the 3rd power for volume would be the yards. You don't take the number to the 3rd power. You're going to get something bizarrely wrong, and you're going to have the wrong units. You take, the exponentiation takes place way to the far right, next to the unit, far away from the number. Okay, so we got that. That was 4. 5. The figure below shows a rectangular window. Okay, there it is. Use the calculator to find the area and perimeter of the window. Make sure to include the correct unit. So that's A. The area and the perimeter, they said there, I think, didn't it? Yeah, right. So the area would be length times width. Area is length times width is this times that. That's a pretty interesting way to look at it. I think, again, I don't have a calculator on me. Let me just kind of do it in my head here. This is 2 times 34. This is 34. 34 times 34 times 2. Well, 34 itself is 2 times 17, and then 2 times 17. 17 times 17 is, let's just see really quickly, you guys, if I could figure out how I'd want to say what that is. So for 17 times 17, we said 225, 220. Let me just see here, guys. For some reason, I'm having a little bit of an issue getting this one under control here, a little bit. 17. So if you took 17 and squared it, it is, let me just some stuff in my head here. Forgive the talking I'm doing here. So I'd say 225 and add, let's see here, you add 30 and 30, that's 60. So 289 basically, I just want to make sure. 289, then you'd multiply that by 4 and then multiply that by 2. You're basically going 889. Well, might as well, I thought I could do some of this in my head. Maybe in the past I could a little bit better. You're doing this right here. Okay. Yeah, that's what I'm getting for an answer here. 2312, 2,312 inches by inches, that's inches squared. Assuming I did that right. I was trying to, the way I was doing it, I could have just done 34 times 68. Issue. I mean, you go here we go, 3 over here. Two, 11, 1. Yeah, we're good. I'm confident with that. So we got that. The perimeter's a lot easier. If you double, if you got 68 and 68, that's 136. If you got 34 and 34, that's 68. So 136. So just the stuff we've been doing in the past, you guys. Recent past right here, I guess you could say. So what do we have? Well, we said 68 and 68. It's going to be 136, and 34 and 34. So because the perimeter, guys, we said that's 2 times 68, which is 2 times this, which is 68. So 68 plus 136. So let's see here. That should be 136, should be 204. And that's inches. Okay, let's just go back. Let's just really double check here, guys. I don't want to lead us down a path. I'm doing this somewhat live at the same time I'm doing all the filming. I'm kind of working this stuff out. So what do we have here? For number 1, we had 52 yards. For number 2, we had 44 meters. For number 3, we had 98 meters. For number 4, we had 64 yards squared. For 5, we had 2,312 square inches for area, 2,312 square inches for the area, and the perimeter is 204 inches. So, I mean, what we're doing here, let me see, they didn't really, the answer to the question here isn't that great here. The glasses window will be replaced. Which measure will be? I don't know, that to me is kind of, I guess I'd say the area on that one, you guys. They didn't really say this. The way the question's being asked is a little on the odd side. I guess I would want this kind of area. I guess I'd want both. I mean, it's a little hard to kind of, hard to fathom what they're trying to say with this whole thing, guys. If you're gonna look to replace glass, you better know the shape that the window's in, and you better know how much glass you need. Yeah, if it's a rectangular piece of glass, you need to know the dimensions of the glass. Which measure would be used to find the amount of glass needed? Yeah, area is what they're going with area. Yeah, they're saying area, which makes sense. Area makes sense. It makes sense, but you need to know the dimensions. You need to know what the sides look like. If I want to replace a window like this, I better know, yes, for sure, I better know that the width is 34 and the length is 68 inches. So area is what they're looking for. I would agree with that. A silver wire will be placed around the window. Which measure would be used to find the amount of wire needed? Well, that's the perimeter, to go all the way around it. So we'll say perimeter for that one. Good deal. We got that. And for go to it. For 6, for number 6, a rectangular field is 115 meters long and 65 meters wide. Give the length and width of another rectangular field that has the same perimeter but a larger area. That's interesting. Well, I'll tell you what we're going to do. Let's find out what the perimeter is if the perimeter will be the same for everything all the way around. If we double 115, we got 230. And if we double 65, we have 130. So we've got, 115 is the length, double it, you got 230, and 65 is the width, double it, you got 130. So 230 plus 130, 230 plus 130 is 360 meters of perimeter. Can you find me something that's got a bigger area than this? It's a good question. Yeah, we certainly can. When they're talking about this, the best rectangular field that's going to give you the most area is square. And the most area you're going to get for a given perimeter would be the area inside of a circle, even better than a square. But for a rectangle, that's what we're kind of looking for. So you're looking at a situation where, you could kind of even say that. You could. There's a lot to be said here. I don't know. Let me go back on that for a second. Let's say a radius r, the circumference of a circle is 2 pi r. if you had that kind of perimeter for a rectangle, the rectangle would have length side 1/4 this. 1/4 of 2 pi r, 2 pi r divided by 4. 2 pi r divided by 4 is pi r divided by 2. That's the length. If you took it and squared it for like a square, you get pi squared r squared over 4. That's interesting. The area of a circle with that kind of circumference is pi r squared. Well, the are equal to each other. How does pi compare to this? Well, this is smaller than pi. Squared over 4 is pi over 4, which is 3.14 something, divided by 3.14 something divided by 4 is less than 1. Something less than 1 times pi is strictly less than pi. This is less than 1 times pi. That's less than pi. This is the going on here. This is bigger. The area of a circle with the same circumference as the area of a circle that has the same circumference as a particular square, that circle with the same circumference as a particular square does have for the perimeter of a circle and the perimeter of a square. Let's say the circumference of a circle, the perimeter of a circle, the circumference of a circle, the perimeter of a circle, and the perimeter of a square are equal. Well, the area of such geometric figures is pi r squared for the circle, and this pi squared over 4 times r squared for the square. This is smaller than that. A circle with the same circumference, same perimeter as a particular square always is going to have a bigger area. That's the most efficient way to encompass area, and that's with a circular enclosure. If you're dealing with rectangular enclosures, if you're dealing with rectangular enclosures, then the square is going to be the way to go. So, can you find, can you find a square that is going to have this kind of perimeter and have 4 sides that are all congruent? Well, what's 4 times 90? You know, the perimeter of a square, each side 90 meters, 4 times 90 would give you the 360. The 90 meters on each side squared would give, that's going to be 8,100 square meters. Yes. So, what was I going to say here? What we're going to? I think I had it. I could have sworn I had it somewhere here. Let's read it. Well, they gave us the 115 and the 65. Why don't you take 65 and multiply it by 115? 115 times 65. You go for it. There's a 2, there's the 7, there's the 5, there's a 0. 3, 9, 6. It's pretty big. What we got here is 7,475. But it's an area smaller than this. So they're asking, again, just to kind of ask the question, I guess you could say, given the length and width of another rectangle, give the length and width of another rectangle that has the same perimeter but a larger area. Its width would be 90 meters. So I don't know, I wrote a whole lot here, guys. So let me see here how we're going to do this. Well, we delivered quite the speech here, I think, I hope. I hope it helps you. And let's keep talking a little bit, I guess you could say. You go to here and you say, okay, well, how are we going to do it then? Well, the width, it'd be a square. 90 meters, you get the 8,100 square meters, which is bigger than the 7,475. I can't remember what I wrote down. There was something on the order of something between 7,400 and 7,500. Well, 7,400 and 7,500 for that area that was originally given, you know, somewhere between 7,400 and 7,500 for the 65 meter width and 115 meter length, somewhere in the ballpark, 7,400, 7,500, that's less than the area of 90 times 90, which is 8,100 meters. We talk about that. So that's 6. See here, 7. Find the area of the triangle below. Well, we had it earlier here. It's basically the area of a triangle is the area is the base times the altitude times the height. The base we'll call 20. That's 20 yards, and the height is 4. And 20 times 4 is 80 square yards. And there you go. That's for number 7. For number 8, there's find the area of this parallelogram. Be sure to include the correct unit in your answer. Let's do it. This is 14. It's 14 down here. It's a parallelogram. So there's symmetry. It's 14 right here. It's 13 right here. But this is the height. 12, and this is the base. Shortcut, there's a number of ways you can do this. I am guessing this is going to come out to 168. Let's just make sure. There's a number of ways, a number of tricks of the trade here on this thing. 2 times 7 is 14. 2 times 6. 2 times 7 will give you 14, and 2 times 6 will give you 12. 2 times 2 is 4. 7 times 6 is 42. 4 times 42 is 168. Absolutely. Pretty neat stuff. That was through 8. So let's just quickly, I do not want to put this stuff on film, guys, unless it's, you know, you hate to make a careless mistake and put somebody in a weird spot here, and then it's not quite as obvious what we're doing. Okay, so we said some stuff. Yeah, I don't know why they gave the answer they gave. Okay, what the answer they gave is okay. They gave for number, like I said, guys, we said a bunch of things here. For number 6, they gave 75 meters and 105 meters. Yeah, I mean, if it's 75 meters in width and 105 meters in length, 75 and 105 is 180. If you double that, you get 360. The area goes bigger. The biggest area you're going to get is right here, 90 by 90. But the 75 by 105 is certainly fine. It'll certainly work. It is going to be a number when we actually knock it out, it's going to be 7,500 plus, let's see what this thing comes out to, plus 3, yeah, 100. Let's just, forgive me here for a second. It's going to be 7,825. Yeah, and that's more than 7,400 to 7,500. 7,800, let me look very carefully here, guys. I don't want to say anything wrong here. Yeah, right, that's fine. So it's going to come out to 7,875, which is more than 7,400 to 7,500. Yeah, the best is this one, though. It's going to be bigger than any of them. This is bigger than this right here, than the other one that we pointed out to as well. 7, we talked about this. It came out to, good, I'm glad we looked. Please ignore what I just did. It's 1/2 base times the height. So let's do that one over. Please strike that. Not sure what I was thinking, but I was thinking wrong. Let's try it again. The area of a triangle is 1/2 base times the height. That is going to be 1/2 base. The base is 20. The height is 4. Half of 20 is 10. 10 times 4 is 40. 40 square yards. I'm not, forgive me guys how I did that earlier. This is what you need to be looking at. Okay, this one did come out okay though. It is 168 square feet. And we got that right there for number 8. Let's go to number 9 and take it from there. All right, let's go for it. Let me erase this, guys. I was going to pause it here. I don't think hopefully it doesn't take too long to do this. Okay, so question 9 of 20. A rectangular garden measures 29 feet by 39 feet. Surrounding and bordering the garden is a path 3 feet wide. Find the area of this path. Be sure to include the correct in your answer. Okay, so this is sometimes just understanding what's being asked is kind of its own challenge. They're doing fine the way they're asking the question, but I want to be careful and answer it the right way here, if I can. A rectangular garden measures 29 feet by 39 feet. Surrounding and bordering the garden is a 3 foot wide, is a path 3 foot wide. Find the area of the path. Be sure to have your answer right. Okay, so here's what we're going to do. You got to be careful here. There's some assumptions you got to make, and that's why they got this thing called Occam's razor, I guess. If this is 29, did I say? Yeah, right. 29 feet, and this is 39 feet, and the path goes around it. We're going to have to use Occam's razor on this one, guys. We're going to make it a rectangular path. Doing something like that. Now, what did they say? Is a path 3 feet wide. Okay, well, 3 feet wide. So this right here is 3 feet wide. So is this. All right, this is the only way I can think of how they're trying to say this. I mean, this is the same thing. This is the same thing here. This is not. That's a hypotenuse. It's going to be longer. But this is the way I think they're trying to play the game here. Well, let's get it together. Let's do this right. If this thing is 39 feet long, what do you say? This is not the only way to do this now. Why do you say you take this guy, and you take this guy, and this is 3 feet, this is 3 feet, and this is 29 feet, and that's the whole length that way. And the width is 3 feet here. We're doing the same thing up here. 39 feet, 3 feet, 3 feet. And this right here is 3 feet. And then we could talk about everything else. So look, I'll tell you what, this is probably one of these things that's easier done than said. Let's be careful. Well, let's be careful. Area is area. I'll tell you what I'm going to do. This is a rectangle down here. I don't want to draw too much here. I mean, I say I don't want to draw too much, and now I go drawing, right? So that's a rectangle, and this is another rectangle. So area of this rectangle, small one, and area of that rectangle, small one, is identical. Area of this rectangle, big one, and area of this rectangle, big one, they are identical. So let me get the area. Let me get the area of the big one and then double it. Well, I tell you what is 3 feet and 39 feet and 3 feet? That's this whole length right here, you guys. 3 feet and 39 feet is 42 feet, plus 3 feet is 45 feet. 45 feet length, 3 foot width. So 3 times 45. And you're going to double it because there's 2 big ones like that. Then you're going to double the small ones. This right here is 29 and width of 3. That's it. And there's 2 of them. Okay. 3 times 45 is 135. Double 135, you got 270. 3 times 29 is 87. 3 times 29 is 87. If you double 87, you get 174. Sounds good to me. Add them together, you get 474 square feet. Not particularly difficult, but a little bit of a lengthy problem. In a lot of ways that mistakes can be made if we're not careful. That's problem number 9. Let me, like I said, you saw the adventure we had earlier when I initially made the mistake with the area of a triangle. It's 1/2 base times the height, not just base times height. Base times height is for a parallelogram. Half of that is for a triangle. So let's see what we got here. Looking at it. Number 9. Okay, I'm already getting different numbers here. Why is it doing that? It's doing that because I'm wrong. Actually, let's do that again. 270. I'm not sure where I got that, but I was wrong. All right, but that's right. You're adding these two. You're adding it carefully. So am I, hopefully. And despite the mistake I made, there it is. That's the right answer. Okay. Let's look at 10. Brian is planting a rectangular garden in his backyard. Brian is planting a rectangular garden in his backyard. He wants the length of the garden to be 5 yards. The area of the garden must be at least 30 square yards. Brian needs room to plant all his seeds. Write an inequality that describes the possible widths in yards of the garden. Use W for the width of the rectangular garden. Okay, not too bad. Not too bad of a look here. Look, he wants he's planting a rectangular garden and be 5 yards. The area of the garden must be at least 30 square yards. So the area is length times width. the area has got to be at least greater than or equal to 30 square feet, 30 square yards rather. Area has to be greater than or equal to 30 square feet. Well, the area we said was length times width, and that's got to be equal, the length times the width has got to be greater than or equal to 30. They are telling us he wants the length of the garden to be 5 yards. And the area of the garden must be at least 30 square yards. Brian needs room to plant a seed. Writing quality describes this. So he wants the length of the garden to be 5 yards. 5W is greater than or equal to 30. Sounds good to me. Divide by 5 on each side. There's no switch of polarity here in the inequality. It's still going to point in that direction to our right. Divide by 5 on each side. And that should be what we're talking about. Like I said, guys, I'm always a little apprehensive. I want to make sure I read the stuff right. I want to lead you guys on the wrong path with this stuff. So this was, which one was that? Yeah, W is greater than or equal to 6. Absolutely. Absolutely. All right. So that looks good. That's 10. What about 11? Well, see what 11 has to say, you guys. 11 is saying the circumference of a circular lot is 248 yards. What is the diameter of the lot? Round your answer to the nearest tenth. The circumference, well, let's talk. I mean, the diameter D is double the radius. Let's remember that circumference is 2 pi r. It's also pi times the diameter. You know, if 2r is the diameter, pi times the diameter, so these are the same. I mean, because 2 times r will give you the d here. The diameter is 2 times r. So the circumference of a circular lot is 248 yards. What is the diameter of the lot? Round your answer to the nearest hundredth. If you want to find d, divide by pi on each side. You know, remember, it's like this, guys. C equals pi times the diameter, divide by pi on each side, and then the diameter, you know, divide by pi on each side, and the diameter is going to be C over pi. So the diameter is going to be C over pi. It's that simple. If you plug in, again, I'm going to go with the answer that they gave in the book, just to kind of cover ourselves with this. Like I said, I don't have the calculator on me right now. That's not a big deal. You have a calculator at your convenience when you're doing these. Let's know the procedures, and the rest is not really going to be an issue for us. What we have here. D, the circumference, that's number 11, right? Number 11. The circumference of a circular lot is 248 yards. Divided by pi, which is, 3.1415926 and a whole bunch of other stuff. Take it out as far as you can take it and then make the round off like they ask you to make the round off. It's going to be somewhere in the ballpark, probably of 80 something. Let's have a look here, what it is for the diameter. Somewhere there, or at least high 70s, maybe. So let's see, let's have a look. How they're giving the answer. 78.94 yards. Let's see what we got. Yeah, 78.9 yards. And there it is. That's 11. 12. Diameter of a circle is 8 feet. Answer the parts below. Make sure that you use the correct units in your answers. A and B here, okay? So for 12, the diameter of a circle is 8 feet. If the diameter is 8 feet, and diameter is equal to 2 pi r. Forgive me, if diameter is 8 feet and diameter is 2 times r, that's 8 feet. 2r is equal to 8 feet. Divide by 2 on each side, so you got the radius is 4 feet, just for the record. The radius is 4 feet, and that's pretty close in a lot of regards, if you're talking about area and stuff, to be sure. And the diameter is 8 feet. Yeah, diameter is going to be twice as long. Diameter is twice as long as the radius. Okay, we know that. See what they want to say here. Make sure you use the correct units in your answers. Okay. Find the exact area and circumference of the circle. Write your answers in terms of pi. Okay, if you write it in terms of pi, you can do that. Okay, so let's actually get there. For A, area, and this is exact, and they're saying what? Area, exact area and circumference. Area and circumference here. The area is pi r squared. In terms of pi, leave pi as is. Leave pi as is. You leave the pi as is. R, notice you pi r squared. You are not ever doing this. The quantity pi r squared is pi r squared. That's times r times r. Getting back to what I said earlier, remember when we were doing things related to related to compound interest, and I said you're only exponentiating the thing that's in brackets or parentheses. You're only exponentiating that thing that was in parentheses. You got an answer after you exponentiated what was in parentheses. When you got that answer, after you only exponentiated that, what was in parentheses, once you got that answer, then you multiplied it by the principal. Same thing here. It's always implied that it's really implied. It's equal to this, and it's implied, you guys, that this is the only thing being squared. That guy right there, or you could write it like this. I mean, there's a lot of, I could probably confuse you more than I'm going to help you at that point. This is probably the best way to kind of look at it. So it's pi times r times r. So we're doing that. Pi times r squared. R squared. R is 4. If you square 4, it's 16. It's 16 pi feet squared. For that. And for the circumference, that's 2 pi r, which is the same as the diameter, or which is the same as pi times the diameter. Well, the diameter is 8. 8 times pi, and that's feet. That's linear units. So just be aware of that when you're doing this. That's the area we're talking about right here. This is the circumference we're talking about. Right there. And let's just, like I said, always like to check what's going on, guys, just to be on the safe side on this stuff. Yeah, for A, and the way we're writing it, 12 is right here, man. So 12 is right here. This is 13. So 13, what do we got? We've got, or do we? No, it's still, what am I talking about? Sorry, guys. Okay, let's just say it again. So here's 12, and this is still 12. This is still 12. And what do you got? I mean, when we're looking at it, 16 pi feet squared, 8 pi feet, sounds good. And then for B, a little different dynamic here. Approximate the area and circumference of the circle. To do the approximations, use the pi button on the ALEKS calculator and round your answers to the nearest hundredth. Or you can just use your own calculator. That's not a big deal we're going to make right now, guys. This is about this is 16, this is 3 something. If you multiply them, you're going to get 50 something or close to 50 something. Well, it turns out the approximation is 50.27 feet squared. That's pretty important. Or at least that jives with this. I mean, 316 is in the ballpark of 50. So that's what we're getting here. 3 something times 8 is in the ballpark of 25. And this one's 25.13 feet. So kind of neat. Here's your circumference with a good approximation. And here's your area with a good approximation. And that's that. All right, so that gets us through 12. Let's go onward through 20. Let's just go like that. I think it's okay. It's not too bad. I think it's going to help you guys out. So let's go from 12. Let's go to 13. Let me put this on pause for 1 second, and then I'm going to come back. Hello again, everyone. Okay, I paused it so I could erase the board and put some other stuff up here. We got through problems 1 through 12. Let's go 13 through 20 and see what we can say, and always be confirming here how the answers are in the answer key as well. For problem number 13, they're saying a training field is formed by joining a rectangle and 2 semicircles as shown. The 2 semicircles, if you put them together area-wise, are the area of a circle. Remember that. The rectangle is 99 meters long and 76 meters wide. Find the area of the training field. Do not round any intermediate steps. Round your final answer to the nearest hundredth and be sure to have the correct unit. Okay, what we're going to do. We are going to find the area of this rectangle. And that is going to be length times width. Then we are going to take this half circle, put them together and have a whole circle, and pi r squared is going to be the area of that. What we have is 99 times 76, and 99 times 76, that's a little easier to do if you even with math that's done in your head, I guess. 7,600 minus 76, it's 7,524. 7,524 for this, and this right here is the diameter of the circle when you put it together. So the radius is half of that, which is 38. 38 feet. So it's going to be pi r squared. 38 is, and there's 2 of them, right? So it's 1/2 pi r squared plus 1/2 pi r squared, which is just pi r squared. It's this right here. If you grind this out, don't round anywhere until the very end, they are going to tell you that for this, it's going to be, we do all this, and we said this came out to, we actually do a 75.24, and then plus this. At the end of all that, rounded to 2 decimal places, this thing is going to be 12,000. 12,060. 12,060.46 meters squared. And there's your answer for that. 12,060.46 square meters. meters squared. Here's the flower garden. A flower garden is shaped like a circle. Its radius is 20 yards. A ring-shaped path goes around the garden. The width of the path is 5 yards. The gardener is going to cover the path with sand. If one bag of sand can cover 8 square yards, how many bags of sand does the gardener need? Note that sand comes only by the bag, so the number of bags must be a whole number. So you've got area A sub B for the bag of sand is 8 square yards. So let's kind of get out of there. Kind of do this so we can kind of see it. And let's talk about what's going to happen here. So that's every bag is going to have 8 square yards. Let me see what I can do here. I am going to take the area that's got to get covered is area of large circle minus area of small circle. The large circle is going to be 5. It's going to be 5. 20 plus 5 is 25 square yards, so it's going to be pi 25 squared. And the other one is going to be pi 20 squared. Radius of 20 and radius of 25. The large is radius 25. The small is radius 20. There's a lot to be said here. You could factor the pi out. You have 25 squared minus 20 squared. Here's the pi. 25 squared is 625. 20 squared is 400. So the area of the path, if they asked us, 625 625 minus 400 is 225. It's 225 pi yards squared. Now, we're not done. They weren't really asking that either. They weren't even really asking that, but we got it. We got this. 225 pi yards squared. If you multiply it by pi, if you go 225 times pi, you're going to get somewhere in the ballpark of 700. How many times does 8 go into the ballpark of 700? Probably like 80, 85 times, 80 to 90 times. It's going to go in there. So let's see what they're trying to say here. Let's see how this goes. Let me erase a little bit, buy some room here. We're going to take that area and divide it by the area per bag. We're going to take 225 pi and divide it by 8. 225 pi square yards divided by 8 square yards. Again, we said it's going to be somewhere in the ballpark. I mean, it's a good question. Somewhere in the ballpark. I mean, where does that go to? I don't know. I mean, this is pi's about 3, 700. It's going to go in there, maybe 90, anywhere from 80 to 90 times, I guess. Let's see what they got. We're going to get a decimal, and then we need whole bags when we're doing this. So what we have here is, when you actually do this, you're getting, like I said, I don't have it on me. I guess I wish I had the calculator with me, guys. I could maybe just close enough, because there might be something good to look at regarding that. Let me see here. Guys, I might have to, let's have a look here. calculator. Let's see what we can say here. Pi times 225 divided by 8. Yeah, 88.373, roughly 88.373 roughly bags. Yeah, but you can't, there's no fraction of a bag that they're going to sell you. You got to buy a whole bag. So you got to buy one up. So it's 89. So it's 89 bags. Here we are, guys. For that one. And that pertains to number 14. It's 88.3573 bags. You can't get a fraction of a bag. You got to buy the whole bag. So you got to buy one up, one more than 88. That's 89 bags. So we're looking good. That is 14. For 15. Let's see here. For 15, they're saying, give me the volume. So let's see. Let's go right about here. Give me the volume of this thing. Well, the volume of this thing is length times width times height. The volume is length times width times height. That's 4 times 4 times 4. Those are cubic units. When you're talking about volume, we're talking about cubic units. 4 cubed is 4 times 4, which is 16, times 4 is 64. And that's for number 15, you guys. That's for number 15. 64 cubic units. When you're talking about volume, you're talking about cubic units. Never cube the number. Never take that 3 and bring it over here. If you cube this, you're going to get an outrageously huge number. You're not going to have the units, so you're wrong by not having the units, and you're wrong by having a number that's way too big. You're only dealing with the numbers. If you're going to talk about cubic units, you're talking about volume, and it's right next to the far right-hand side of the unit. To the far right-hand side of the unit is where you put the cube. When you're talking about squares, you're going to the far right-hand side again, and you're talking about square. Two-dimensional space, that's area. The square is far to the right next to the unit, not next to the numbers. The cube is talking about three-dimensional space, the third power, not next to the number, far away from the number, just like over here, far away from the number, to the far right, always next to the units. Okay? So we know that. That was 15. Let's just kind of always confirm, guys. It's been a little bit of a challenge trying to put some of this stuff together here. Find the volume of the rectangular prism. Okay, pretty straightforward. For number 16, a company makes. For number 16, so let's figure out how we're going to write that. For number 16, a company makes paper labels for paint cans, as shown below. Each can is in the shape of a cylinder with a height of 5 and a diameter of each can has a height of 5 centimeters and a diameter of 4 centimeters. So if the diameter is, height of 5 centimeters, right here, height of 5 centimeters, and diameter of 8 centimeters. So the radius is half the diameter in terms of magnitude, so that's 4 centimeters for the radius. Okay, we'll keep that in mind when we're doing some of this stuff. If that's 8, this is the radius, 4 centimeters, right here to here, okay? And let's see what we can say here. So height of 5 centimeters, diameter of 8 centimeters, and radius of 4 centimeters. The paper label is wrapped around the can and covers only the side of the can, not the top or the bottom. So we're just talking about right on the side. The company uses on average 5,546.43 square centimeters of paper each minute making these labels. How many labels does the company make on average each minute? Well, we've got to see what comes in there. For your calculations, do not round any intermediate steps and use pi on a calculator. Round your answer to the nearest hundredth. So we will find this area outside of the cylinder. And we're basically finding out how many are going to be made. We'll say n is the number made, and you're doing 5,546.43 per minute, area-wise. That's how much paper you minute. That's how much paper you per minute. Find out how much one of these is, and how many times one of these goes in here tells you how many they're making per minute. Well, what's the area? This is the area of the can. A sub C, let's say. And this is the number that we're going to get. Well, I tell you what I'm going to do. I mean, the way to kind of get here is, and let's, like I said, we pull these out of here now. We've already done these. Well, let's find out what the circumference is and then multiply by the height. I mean, I guess a rectangle, you guys, is, length times width, or length times height. The height of the, length times width or length times height, and that'll get you there. Well, if this thing is wrapped around in a circular manner, the length is going to be 2 pi r. And the height is what it is. So the area of the can is 2 pi r, is 2 pi r times the height. And that's going to be 2 pi. The r is, the r is 4, and the height is 5. Well, that's kind of interesting. We can kind of wheel and deal with that a little bit. 4 times 5 is 20, times 2 is 40, or you can go 2 times 4, 2 times, leave the pi there for now. 2 times 4 is 8, times 5 is 40. Now throw the pi in there. That's yards, right? Now what do we say? That was centimeters, rather. I'm sorry. That's the circumference here. Centimeter squared. Talking about. We remember it amounts to the area. This thing's, when you fold this thing up, it's looking like this. When you unfold it, you get that. You get something looking like that. So you got this. So what do we got here? We've got n is 5,546.43 square centimeters divided by 40 times pi, which is like somewhere in the ballpark, somewhere in the ballpark of 120, 125, 120, 125 square centimeters. Divide these. First get the whole answer before you divide. Go 40 times pi, get the answer set there, divide it into here and see what it does. It's pretty interesting matter in its own right. Let's have a look here. Okay, let's see what we can do. Five 5,546.43. Yeah, I mean, I'm getting the answer of 44.137. How many cans it's going to do in a minute? I mean, I'd like to. Yeah, it looks pretty good. See how they're interpreting the results there. It's a question of what you're going to call, how they want to say it. I guess they said nearest hundredth, so let's kind of be respectful of that as well. I got 44.14 labels. That's what they got. I mean, that's we're not there yet. They said round it. So N 44.1371 tenths hundredths right here. It goes up to a 4. Right, so that rounds off, and that should be your answer for number 16, you guys, as we got it. That's how they wanted it. They said, okay, you're doing a fraction of a label. You're not quite done with it. After that minute, you're doing 44 and then some for the labels. And let's just see how that works out, guys. Right, so let's see how it's asking here. For your calculations, do not round any intermediate steps and use the pi button on a calculator. Round your answer to the nearest hundredth. So they wanted to take it like that. We took it pretty far. We took it to the nearest 10,000th, and then afterwards we, nearest 10,000th or so, and then we just rounded to the nearest hundredth, and that brought it to 44.14. Okay, very good. Regarding 17, they're asking some interesting questions there as well. So for 17, they're saying a grain silo has a cylindrical shape. Its diameter is 16 feet, and its height is 36 feet. Answer the parts below. Make sure that you use the correct units in your answers. We know a lot. I think we're going to be okay. So let's see if we can actually do it. Find the exact volume of the silo. Write your answer in terms of pi. For that right there, let's erase. Again, I always forget we've got the film on this, so we're okay. So let's start walking, get ourselves a little bit of room to do some of this stuff. Okay. When I start erasing stuff I don't need to erase, guys. Okay. Or okay, we got it. We caught it good enough, I guess. All right, so find the exact volume. What we're talking about is, for the volume, it's pi r squared times the height. That's the volume of a cylinder. So pi is pi. The diameter, this is the diameter. The radius is half of the diameter. The radius is half of this. It's 8 feet. So let's go with that. pi is pi. This is 8 feet squared times the height, which is 36. Let's see what we got here when we're doing this. Yeah, a grain silo has a cylindrical shape. Its diameter is 16 feet, and its diameter is 16 feet, and its height is 36 feet. Find what it is. Well, I mean, there's a lot here. 8 squared is 64, and 36 is 36. So what we got here is, if you actually multiply that out, you got 64 times 36, and there's shortcuts to this, but I don't know, maybe the shortcuts take as long as just doing this old school, writing it out. 6 times 4, 24. 6 times 6 is 36, and 2 is 38. Put a 0 here. 3 times 4 is 12. 3 times 6 is 18, and 1 is 19. 4, 10 right here. 13. 2304. 2,304 times pi cubic units. You're not cubing this. You're going to the far right and cubing the units. That's the exact volume. That's A. 17A. 17B, using a calculator, approximate the volume of the silo. To do the approximation, use your answer to part A and use the pi button on the calculator. Basically, you just take pi, multiply it by 2304. Take pi, multiply it by 2304, and that'll give you where you're supposed to be. And that's about, 7,000 something, or somewhere in the ballpark of 7,000 something. Let's have a look where it is. Always gives us a chance to check what we're doing, guys. Yeah. 2,304 pi, 2,304 times pi, so you just say pi, means multiply, 2,304 pi feet cubed. If you put 3.1415926 and a whole bunch of other stuff in there and really grade it out, it's going to come up to ballpark something. 7,238.23 cubic feet. Notice the cube is way, way to the right. The cube unit, the square unit and the cube unit, square units for area, cube units, square units for area, the cube units for volume, they're always to the far right next to the unit. Cubing the number, as we said. So watch out. Let's not do anything careless. That's 17A and B. Okay, so okay. See what we can say here, guys. So what 18 is asking a pretty fascinating question as well, I think. '18, the solid below is made. Now, I'm going to have a real hard time drawing this, guys. I'm going to have to refer everyone. Those who are in my class can see it in the handouts I've given. Everybody's going to have this scanning at the very end of this video. So just watch what's going on there, guys. The solid below is made from 1 meter cubes. 1 meter on each edge. That means 1 meter cubed cubes. Perhaps that could have been brought up differently, could have been said differently, perhaps. I'm not sure. The solid below is made up from 1 meter cubes. 1 meter on each side of the cube. Find the total area. Find the total surface area of the solid. Be sure to include the correct unit in your answer. Well, it's going to be area. It's going to be square units. The way I'm looking at it is 1 meter on each side. Each face has, it's 3 meters. It's going to be hard to say this, guys, without drawing it. And drawing it would be a real, kind of a real mess, to be honest with you. So let me just kind of say, when you do refer to this at the end of the film, look at problem number 18 and get an idea what I'm talking about. The face has the face is 3 by 3 in terms of it's 3 meters by 3 meters. And that's happening on each side of the edge. I don't know what they're talking about here. Are they talking about what's underneath it as well? Find the total surface area. I'm assuming they want all the area, including what's underneath. Well, the very front part of that figure is 3 meters by 3 meters. It is a cube, 3 meters by 3 meters by 3 meters. It is a cube, 3 meters by 3 meters by 3 meters. Well, 3 meters times 3 meters is, 3 meters by 3 meters is 9 square meters. There are 6 faces to that dice, to that one die, I guess you could say. 6 faces, each one of them looking like this. So that's 54 meters squared. You're not done, you're just started right there. The other one has on top of it, it is 3 by 2, and it's 3 by 2 in 4 places. So 3 by 2, 3 by 2 is 6, and it's in 4 places. So, so let's see what we're going to say on that one. So so you plus that too. There's 3 on the bottom, 3 meters, 2 meters. 3 by 2 is 6, and there's 4 faces that have that. So 4 times 6 is 24. And the 2 sides are 2 by 2, so 2 times 2 is 4, and there's 2 of them. That's 8. And then there is the other part of it, which is 3 by 2 and 3 by 2, which is 6 plus 6, which is 12. And then the far back end is going to be 3 by 5, which is 15. That's quite the mess. You're going to have to look at it to try to see where these are coming from, guys. But this is what I just told you. I'm assuming they want the underneath as well. And did we get the underneath? Okay, so let's just make sure we did. So what did we say here? We had 6 of these. 6 by the 9. 6 by 9 is 54. Then we had 4 by 6 is 24. So we already got the bottom on that one. And then okay, let me just see here, guys. So when you look at it, I think it's going to make a little more sense. So look at the front part of the cube. It's 3 by 3, and there's 1, 2. Let's see here. There's 1, 2, 3. It's very interesting how we could actually do this. We got to be very careful. Let's see how this is going to work out, guys. There's 3 by 3, 3 by 3, 3 by 3, 3 by 3, 3 by 3. There's 5 3 by 3s. There's 5 times this, actually, because one of them is glued to the thing. So there's 5 of these. And, okay, let it go. And then come over and say, okay, there's 6, there's area of 6, and another of 6, and another of 6, and then yet another of 6 way on the bottom. So that'd be 24. We'll let that go. That's a little throwing the dice a little bit, but 4 times 6 to get that. Then we have the sides is going to be 6 and 6 is 12. And 4 and 4 is 8. And then 3 by 5 is 15. I think we got this thing now. 15 and 45 is 15 and 45 is 60. This right here is 20, so that's 80. That's 104. It's got to be looked at. You're probably not going to do much, but it's legitimate. Can you get the surface area? Can you get the surface area? Well, depends how they're making the measurement too. They might not be counting stuff that's underneath. Well, if they're not counting the stuff that's underneath, I wish they would have told us that. So let's see, I'm getting 104 here. They're saying 98. So I'm trying to think, where are they getting 98? See, 98. I don't know if I believe it, but let me try it again. Are they going underneath? That's the only thing I can think of. But that's got to be. Let me see here. There are 1, 2, 3, 4, 5. 5 times 9 is 45. That's covered. We've got 6, 6, 6, and 6. That's 24. Covered. The 8 and the 8, forgive me, the 4, the 2, that's 4 and 4, that's 8. Then 6 and 6 is 12. Yeah, I don't know. Am I just not doing something right here? I actually am making, I think we did 60. Yeah, I do not know. How are they getting 98, you guys? I do not know. Let me think about it. I'm thinking not the 6 underneath and not the 9, 15 short of that. Trying to think about this one, guys. Tell you what, let me try this another way. 9, 9, 9, 9, and okay, let's go like that. Let's go 4 times 9 is 36, plus 15. 3 by 5 is 15 on the bottom. 3 by 9 is 15 on the bottom. 4 by 9 is 36. So 36 and 15. 36 and 15 is 51. Plus another 15. That's 76. 76, 84. $96. I don't know where they're getting these numbers, guys. They must be not counting something. I can't for the life of me figure this out. Let me just try it again. Tell you what I'm going to do. I'm going to take I'm going to take everything on the outside and just take it from there, maybe. I'm going to go 9 and 15 is 24. Okay, let me do that. Let me go on each side. I'll go on, I might try a different approach here, see if I'm going to get the same numbers that they're getting here. Somehow they're not getting the numbers I'm getting. But let's see what we got here. 9 and 10. Okay, that's a good point. I might be doing something wrong here. Let's see. There's 9 and there's 10. 9 and 10. 9 and 10 is going to be 19. Get on the other side. 19 and 19 is 38. 38 underneath 15 onto 38 is 53. 53. Another 15 is 68. That's 68. 9 and 9, 68 plus 18 is going to be 86. 86 and 12 is 98. Okay, I do stand corrected, guys. It does work. How it works. I mean, this actually, probably need to draw this actually, to be honest with you. Please forgive the hassle here. This is not going to be the way it is. Okay, here's what you're going to have to do. It's going to be a rough one. To draw, maybe, I'll do my best and try to make it make sense. We'll throw the answer here. Turns out they're right. It is 98. And man, it's a rough way to. I wasn't sure where I was looking. Still not quite sure, but let's go with what they said. They said 98 square meters. The area is going to be 98 square meters. Be sure of that, and hopefully now I can explain it. And maybe this is for the better that we're at it right now with this whole thing. So 98 square meters is what it is, and what the heck? Let's go pretty old school on this, if we have to. Had no intention of drawing this, but was not coming out right. They're right. I'm wrong. So let me show you. Let me show you why I was wrong. Let me show you why they're right. Maybe that's a better way to do it. Regarding 18, they got this thing drawn. I don't know how I'm going to draw it, guys. This is not going to be my forte, drawing something like this. But they're saying, okay, do this, then do this, then do this. This is why I didn't want to draw it in the first place. This is looking like a joke, but well, pretend I knew how to draw, which is really pretending. I mean, and this, and then 3 of them here. This looks worse every time I look at it, but okay, this, And there's 3 over here, guys. And this is a rectangle going straight up. It sure doesn't look like one, but 1, 2, 3, 4. 1, 2, 3, 4, 5. Okay. Yeah, that's really not looking good. But okay, so here's their argument. Here's how you're going to get 98. Each one's a meter by a meter. So I'll tell you what I'm going to do. I got this thing kind of doing this. This is on one side, and the same thing's happening over here. This is 1, 2, 3, 4, 5, 6, 7, 8, 9. 3 by 3. 3 times 3 is 9. 2 times 5 is 10. 10 and 9 is 19. That's this right here. So this is 19, and it's taken care of. And on this side, there's 19. So there's 19 here, and there's 19 there. So $19 here. Okay, 19 here, and 19 here. So 19 and 19, it's 2 times 19, and you got all that. Let's go for it now. Underneath, it's 3 by 1, 2, 3, 4, 5. 3 times 5 is 15 underneath. Go to the back end of this thing, the back end over here, and that's 3 by 5. That's another 15. And now I got everybody except for 3 by 3, which is 9. 3 by 3, which is 9. 3 by 3 is 9. 3 by 3 is 9. So there's 2 3 by 3s. There's 2 9s. 2 9s. There's 2 by 3, which is 6. 2 by 3, which is 6. There's 2 6s. And I think we got everybody. I was trying to do something else that wasn't quite as logical. But the way you want to do it is take this big mess, which is 3 by 3 plus 2 by 10. 3 by 3 is 9. Forgive me, yeah. Take this mess right here, which is 3 by 3, 9, plus 2 by 5, which is 10. 9 and 10 is 19. There's 19 over to the other side. So 2 times 19. Get what's underneath, which is 3 by 5, 15. What's on the other side, which is 3 by 5, which is another 15. 15. That's about it. Now just look at what you're looking at. Look straight on right here. This is 9 and 9. So that's 2 by 9. And this is 6 and 6. That's 2 by 6. And that should be the 98. Let's see what happens. We've got 38. Add these two. We got 30. Take these two. Double this. You got 18. Double this. You got 12. I think we're there. This right here is 30. This is 30. This is 38. You add them together, you got 98. They were right. I was wrong. Well, at least we're caught. At least we get it. At least we get it caught. At least we catch it. It's a lot easier to do it. And I thought I could do it without drawing it. Well, you got to draw it. I think probably drawing it's the best way to go. All right. That's 18. an easy one. Not an easy one, you guys. Makes you think. All right. And here we are. We got it. For 19, consider a sphere with diameter 12.8 meters. If the diameter of the sphere is 12.8 meters, something good to know when you're talking about surface area. The radius is going to be half as big. Radius is going to be half as big as the diameter. So here we go. What do you want to say about it, guys? Well, okay. It's quite the mess, isn't it, sometimes? Let's leave that up there. We worked hard enough. For 19, consider a sphere with diameter 12.8 meters. Using a calculator, approximate the volume of the sphere. To do the approximation, do not round any intermediate steps and use the pi button on the calculator. Round your answer to the nearest hundredth. Make sure that you use the correct units in your answer. We're talking about, use a calculator to approximate the volume of the sphere. The volume of a sphere, the volume of a sphere is 4/3 pi r cubed. Volume of a sphere is 4/3 pi r cubed. Let's talk. I mean, 4/3 is 1.33 going on forever. Pi is about 3.1415926. The radius is going to be 6.4. That's the only thing getting. This is the only thing getting the radius. Don't multiply. I at least see a lot of people do this. Don't multiply something all the way out. Don't multiply something all the way out and then multiply it all the way out and then cube it. No way. The only thing you're cubing is the radius. Just this. All right? Well, okay. I mean, we'll grind this. We got to be careful with it when we should be okay. Let's trust what they're doing. You get an answer. It might be pretty big. And it might have a lot of a decimal expansion. Will have a lot of decimal expansion. But you do this to the nearest hundredth. $1,098 1,098.07 cubic meters. Okay. And there's the cube, guys. The cubic meters is right next to the unit, not next to the number. I mean, you know this. I don't want to beat this up too badly, but and there you go. It's number 19. So for number 20, erase a few things here, guys. It should go pretty smoothly. After problem 18, I think the problems after that are pretty decent. But it's good stuff. It's good to make yourself think. Even quote unquote easy problems are easy to get wrong. And if precision's required, and like you really got to make sure you got this right. If you're an engineer or a medical professional, or anything, engineer, medical professional, anything, nurse, paramedic, there is the idea of precision. Notice how quickly I could get that wrong. We had to look at it again and we got it right. It takes more than one look, obviously, sometimes, and even the quote-unquote simple problems aren't really simple. For number 20, If we're careless, as I was, and we caught it though. I caught it, and we looked at it, we got it, But if you're careless, if we're careless, anybody can be, we can get it wrong. They're saying here, consider a sphere with radius 3.9 centimeters. Using a calculator, approximate the surface area of the sphere. To do the approximation, use the pi button on the calculator and round your answer to the nearest hundredth. Make sure that you use the correct units in your answer. Okay, volume of a sphere, we already know. We did this. And there's some fascinating derivations as to why that's true. The area of a sphere, and that's the one we want. And that's what we're doing. That's what we're doing. So we're gonna work it that way. Well, that's not too bad. That's not a bad deal for us. The area is going to be 4 times pi times the radius squared, which is 3.9. Again, what's getting squared is just the 3.9. This is not going to be cubic units because we're not doing a volume like we did in problem 19. For problem 19, we did a volume. That's cubic units. It's a different story. 4 times pi times 3.9, the quantity squared. I could look at this. I mean, 3.9 is 3 times 1.3. If you square the product, 3 times 1.3, if you square the 3, you get a 9. If you square 1.3, you get 1.69. If you go 9 times 1.69, you get 16.90 minus 1.69. It's a long story. So if you do that, you're going to get 16.90 minus 1.69 is going to be 15.21. It's going to be somewhere in the, it's going to be times 5. It's going to be 15.21 times 4. Well, 15.21 times 4. Let's see here exactly, guys, what's going on with that. I want to make sure. Right. Yeah, I'm going to say 15.21 times 4 is 60.84 times pi. What do they got here? Centimeters. All right, that's a real throw of the dice, guys. I'm thinking, did I even get that right? I think I did. I mean, I think 3.9 is 3 times 1.3. If you square that product, 3 times 1.3, 3 times 1.3, square that entire product, you get 9 times 1.69. 1.69 times 9, this is 54, and 8 is 62. Well, at least I got something right today. I got 15.21. When I multiply that by 4, I should get 60.84. This would be actually the exact answer if they were asking it. Well, I'll tell you what. They're not asking that. But let's go pi times 60.84 and see where this is going to go. And we're going to round it to the nearest 100. So what we got here, they got 191.13 square centimeters. 191.13 square centimeters. 191.13 square centimeters. Let's just see if that's actually true. Well, I believe they did a good job thus far with this stuff. They're not. I'm thinking this is the exact answer in terms of pi, but nobody asked you to give that. But you can use this to get that answer rounded to the nearest 100 if we did it right. Let's have a look. I'm going to go 60.84 times pi. That's 191.1344. Yeah, it's on. 191.13449. Well, 191.134, if you round, it stays where it's at. If it's more, it rounds up. That's on the mark. That's on the mark. Again, some of this stuff you can do, you saw it. Some of this stuff you can do in your head and you can confirm, hey, we guessed it right, the 60.84. This is the exact answer. They're not asking for the exact answer in terms of pi, and this is the approximation rounded to the nearest hundred. Rounded to the nearest hundredth. All right, guys, that's quite a lot of stuff there. Like I said, I put a pause in the video, so you'll see it at some point where, you know, it looks like, okay, it's starting brand new, and I had erased and went with that. Hopefully I saved a little bit of time with the video. There's a lot of stuff here. All right, thank you for your time. We got 3 more to do after this that we just finished. The questions from the test chapter 5, practice test chapter 5, just like all the other practice tests, are scrolling at the end of each video. For the particular, so for test number 3 video, test number 3 exam, practice exam is scrolling at the end of it so you can see what the actual questions look like. And the solutions are here for you. It should help you out. Take some time with this if you need to look at it. As I said, even things that are apparently simple don't necessarily come out to be simple. So it's always a challenge. Always gets us thinking. Thank you all very much for your time. We'll talk to you soon.